This is A2 Physics, Chapter 3. Select and apply the equation for centripetal force, F equals ma, which also equals mv squared over r. So we know that acceleration equals v squared over r, and that's the acceleration acting inwards when an object is moving around in a circle. And we also know that the force equals mass times acceleration. So from these two, we can deduce that the force acting inwards on the circle must equal mv squared over r. Here's an example. A stone of mass 120 grams is fixed to one end of a light rigid rod. The stone is whirled round at a constant speed of 4 meters per second in a vertical circle of radius 80 centimeters. Calculate the ratio of the tension in rod A over the tension in rod B when it's at B. So we'll start with it at A. It's at the bottom of the path. It's moving at 4 meters per second, and the radius from the circle is 0.8 meters. So we have the tension acting upwards towards the center of the circle, but we also have the weight acting downwards, which equals mass times gravity. In this case is 0.12 times g. So if we use the equation F equals mv squared over r, what we have to remember is that F equals the net force acting inwards on the circle. So in this case, F will equal the tension upwards minus the weight, because the weight is in the opposite direction. And that equals mv squared over r. So from this, tension equals the weight plus mv squared over r. And if we put the numbers in, it equals 0.12 times g plus 0.12 times 4 squared over 0.8, which comes out at 3.577, which is about 3.6 newtons. Now at point B, this is at the top of the circle. It's still moving at 4 meters per second, and it's still got a radius from the center of 0.8 meters. But this time, the tension is acting down inwards towards the circle, but the weight is also acting down in the same direction. So if we use the equation again, F equals mv squared over r, and if we remember that F equals the net force overall acting inwards, so F will equal the tension plus the weight this time, and that's all equals mv squared over r. So from that we can deduce that the tension equals mv squared over r minus the weight, and this comes out to be 1.223, which is about 1.2 newtons. So the question asked us to calculate the ratio between the tension at A and the tension at B. So if we put the numbers in, the tension at A was 3.6 newtons and the tension at B was 1.2. So the ratio between the tensions is 3.